Hi, I'm Stephen Foskett from Foskets.net and Tech Field Day, and I'm here live at the Storage Developer Conference 2012 in Santa Clara with a great group of folks. Once again, let's tell us who you are.
Hi, I'm Robin Harris, StorageMojo.com.
Hi, I'm Jeff Darcy, ClusterFS developer, Obdorodon on Twitter.
Hi, I'm Scott Lowe, other Scott Lowe on Twitter, and I write at CIOscape.com.
Hi, I'm Robert Novak, Gallifreyan on Twitter, and I do business intelligence.
Do you? That sounds very intelligent. Are you as intelligent as it sounds?
A little bit less distributed, but yeah.
Sounds like an oxymoron, like military intelligence.
Yeah.
There goes one demographic.
We just lost that.
Yes.
Well, they only have 40 terabytes of disk, right?
Only 47% of the military is actually intelligent.
60% of statistics are made up.
On the spot.
So,
yeah.
So what did you guys see today since the last time we were on camera? Anybody see anything great?
Go ahead.
Oh, the Linux file system talk this morning.
Wasn't that good?
That was the highlight of the morning.
Yeah, Fusion IO guy?
Yep.
Yep.
He even said nice things about Fuse and GlusterFS, which I very much appreciated.
Yeah, and Ceph.
And Ceph.
Yeah.
Which
but
I
he
didn't care
forgot
much
to
about
mention
at all.
SMB.
Forgot.
So, is it as good as what Microsoft is doing with REFS and storage spaces?
That was actually the other highlight for me, was the REFS page.
Same here.
Did you guys see that?
Uh-huh.
Yep.
That was, again,
Microsoft is really pulling all the stops, I think, from a storage perspective.
Yeah.
it's going to take a little while before it hits the ground.
Before people
that's the thing.
believe it.
REFS, it's not like your new Server 2012 install is going to be all REFS, but this time for sure, Microsoft has tried to replace the file system 3 times now.
Yeah,
and
it's starting to take.
Yeah, this time it'll work. Watch me pull the file system out of my hat.
Third one caught fire, tipped over, sank into the swamp, but the fourth one.
Yep, the fourth one will survive. No.
But I definitely see ways that they can actually leverage some of the stuff that they're bringing out with REFS and storage spaces. Because I'm a big Hyper-V guy these days, apparently.
Apparently.
And maybe a little bit.
Because apparently you love Hyper-V.
I do like Hyper-V. I like the idea of Hyper-V a little bit. And if there's some interesting possibilities there if you can combine everything Microsoft's doing from an availability and scalability perspective.
But REFS looks just tremendous. It basically it's like a wish list file system. Did you see this?
Yeah.
I mean, it's like everything you could want in a file system, which is why I'm concerned that it'll never make reality.
I think the features for data availability and checksumming and things like that's real key.
Mm-hmm.
Well, and beyond, I just spent half an hour with the development team and dove into a couple of questions. One was, they mentioned that they have this API that they expose so that applications can actually go in and decide for themselves which is the right file, for example, if there's a synchronization issue.
Okay.
And just intuitively, that sounds to me like it could be a platform for some real value-added services. Now, what those services might be, I have no idea. But it just seems like, it's the kind of capability that Microsoft traditionally has not exposed. And so people haven't even had the option to think about, what that could mean from an architecture perspective. And the other thing they said was that you can turn off the checksumming and I don't know, the redundancy stuff. I have to look at my notes, but you can turn it off on a directory basis, and they're doing that so database guys, databases have a very good idea of what the data is supposed to be, or at least they should. Don't even have to deal with it, and that's just a level of openness and cooperation, playing well with others that I haven't traditionally seen from Microsoft.
Yeah.
I'm just really impressed by the whole attitude behind.
Did they say what RE means?
Resilient.
Yeah.
Okay.
Resilient.
Because I missed that. I must have been tweeting or something.
When they were talking about checksumming and some of the other data protection features, was there any talk about what kind of a performance impact those have?
Yes, I got into that with them, and there were really a couple of issues. One is that it does generate more metadata, but they said the amount of metadata additionally generated is like less than 1%. So
it better be. I mean,
well, yeah, but I mean, it's not a significant thing. The one that's a little more interesting is because it's no longer a write-in-place file system, your data layout is going to change in ways that you may not expect. So if you're like, totally hyper about how the data gets laid out, you may want to turn some of this stuff off. Although I'm not sure you can turn off the not writing in place.
Well, it's like that's one of those themes of storage, though, that storage nerds have to start letting go more and more of control, of micro control over what is exactly going on. I mean, whether it's wide striping or automated tiering or deduplication, you kind of have to start letting the system do what it does. Cloud storage, distributed storage. The more you try to complicate things, the easier it is to stop up the drain, as Mr. Scott said.
Well, and you got to look at historically why people were such control freaks, and why? Because disks suck, right? And so, in order to maximize performance for sucky disks, you have to contort yourself 12 ways from Sunday. So
and
now,
we thought we'd get away from that with SSDs, and then it turns out that random access on writes for them ain't that great either. So
well, yeah, there's that.
You can't just throw Flash at it.
Right.
And that was actually the cool thing about the Linux file system talk. It wasn't just Linux file systems.
Yeah.
It was talking about like shingled disks and Flash, and how you have to deal with different medium and how that changes the file system and
What is a
challenges the file
shingled
system.
disk? I don't
Tune
know.
in tomorrow for Garth Gibson's
Yes.
talk, because you will learn all about it. Yes.
Give me the 30-second overview.
It's the new kind of disk drive, and instead of basically having bits lay down on a bed like they used to, or having them be perpendicular,
Right.
they're actually overlapping each other like shingles.
Interesting. Okay, because I'm familiar with perpendicular storage, but I've never heard of shingled.
Right.
I see a
It's a
blog post in my
painful
future.
condition.
Yeah.
I
And
understand
there's
that it could be.
really unpleasant stuff on it too.
herpes.
Yep.
But you can actually
Yes,
you
we're
can
live.
you can write
We're live.
you can write with a much stronger current,
Yep.
and because you're not worrying about overwriting adjacent tracks.
Okay.
It's kind of neat how it works. But yeah, that's basically what Mr. Garth is going to be
But
talking
I
about
like the
tomorrow.
helium-filled drives coming from
Yeah.
Hitachi.
I've heard about.
Yeah,
I've heard about those.
they're
Good place to store your Chipmunks records.
Exactly.
yeah.
Yeah.
So,
Is it
I
going
mean,
to raise
the
all
only-
my data in Octave?
Yeah.
Okay.
It just goes
reduces
faster
floor loading.
and higher. And-
Lighter servers.
Scalier.
Yeah. Well, no, I mean, making a drive.
Scale up.
The diffusion capabilities of helium are quite high.
Oh,
so
fusion and helium. Oh, this is
Yes.
going to be a great combination.
Yeah. So.
All right, we're going downhill here.
No. I mean, as a gas, it just diffuses through a lot of materials, right? And disk drives today actually have a channel to the outside world for, to equalize pressure, right? And so these things are going to have to be, they're totally hermetically sealed, and they have to be for the life of the drive. And doing that with helium is just not technically an easy problem. And so, Hitachi said it took them 6 years, and I believe it.
And isn't that going to possibly result in a price spike if they start selling lots of these things? Because helium is not exactly an inexhaustible resource.
Well, it's actually found with natural gas
Yeah,
deposits.
there's more of it than people say.
Yeah,
Okay.
the real issue with helium is not the supply of helium, it's storing helium.
And a lot of companies, even when they're doing natural gas production, don't grab the helium.
Right.
So they've just got to start doing that, and there'll be more helium. I mean, there have been talks about helium shortages and things like that, but as we find more natural gas, we find more.
Don't we have a strategic helium reserve or something?
Actually,
We do.
yes, there is
It's
a company
floating over the North Pole.
There's actually a strategic helium reserve in Canada, believe it or not.
Theirs or ours?
I don't know, but there is one.
just-
If we
debate.
want it, we just go take
Exactly.
it.
Yeah, America.
Does Canada have an army?
Right. Yeah.
Oh yes.
We'd like to apologize to all of our Canadian viewers. We love
We
you.
love Canada.
We're not.
We
planning
think you're
a
very
secret
nice people.
invasion.
That's why we're.
No, it'll be very
Just
public.
bring the
Yeah.
helium to the border.
Yeah.
Nobody will
Nobody
be
gets
hurt.
hurt. Yeah.
They'll bring it in a balloon.
Oh, good times.
So the storage class memory talk was also another interesting take
Oh,
on
yeah.
that now random access takes on another different flavor.
What's your opinion on storage class memory? Is that like a good term or a terrible term?
It's one I've gotten used to. It was there were at least a couple of talks at FAST that used that
Yeah.
term. It
And
seems to be
IBM talks
the
it,
common term.
yeah.
So,
Well, IBM has been pushing it for years. I mean, at least 10 or 15 years. I mean, they've been talking storage class memory. And I think they've just worn everybody out. So people are starting to use the term storage class memory. But your comment about random I/O, flesh that out for me.
Well, now again, we have another technology that is being used for a storage-like role that actually might have flat random access latency. So that could actually be a real game changer if it's used in that way. But it's a weird technology. I was looking at the numbers that he put up, and it really is a lot closer to memory than it is to disk, even to flash-based disk.
Yeah.
So it's probably going to be treated a lot more like memory than like disk. And the thing it reminds me most of, and I'm going to really date myself here, is back 20 years ago when Sequoia made fault-tolerant computers based on the same principle of using regular memory as a cache for this memory that was only updated transactionally. And so I would really like to see a lot more about how the storage class memory interacts with work that's going on elsewhere in software transactional memory, because I think there's clearly a synergy there. Did I really just say synergy?
You did.
You did.
Yeah, crap.
Yeah. You also said interacts. Yeah.
Well, we
Okay.
can leverage the
Yeah.
synergistic interaction.
So how would we implement it?
How would we implement it?
I think it would require a staged deployment.
Yes. Okay.
Yeah, there we go. Hey, System 38 forever, right?
But we do need something. We need something to replace
36?
Flash. You know.
The question
I
is,
thought
what
it
will
was
it
the
be?
System 38 had the flat
And-
memory.
Okay.
I think
where
I think a bigger.
disk and. Sorry.
I'm sorry. I
No,
was interrupting you. You go ahead.
No, I was interrupting you.
No, I'm interrupting you.
Okay, I'll interrupt you. So, it's. I mean, I'm thinking that resistance RAM is going to become the ultimate memory. I mean, they're still playing with the physics of that, but it looks like it's highly tunable. You know, depending on the physics and the composition of the resistance RAM. So we may be in a world in 10 years where you'll have basically all of your memory will be your main memory and your main storage will be the same physical media.
Yeah.
And like the System 38 did it using disk as virtual RAM.
We already do that. It's called paging.
Yeah, but without the pages.
Exactly.
But it's going to be interesting to see where applications go with this.
Yeah.
And you talk to the Fusion IO people about that, and they're really keen on this future. And for good reason, obviously, if your name is Fusion IO. But it's really, I mean, think about how applications change if there's no storage.
Well, the whole purpose of memory is to load things off disk.
Yeah.
I mean, to run fast, right?
Well, no, or you could say the whole purpose of disk is to hold things
Well,
that
yeah,
memory
that's
can't
true.
hold. I guess it depends on your perspective.
Yeah.
Or from a usage perspective, if all of this suspend resume stuff just becomes absolute nonsense because the memory is already
Loaded.
durable.
Yeah. That's
That would be
interesting,
pretty
yeah.
cool. A computer
Because
that
I know-
never has to boot.
And in the Linux world, that's actually a big thing because all of the suspend resume stuff is a major pain. It's full of fiddly little corners that people have to reverse engineer and figure out how to do it right.
Every
And
company does it exactly the same, don't they?
one company does it in a fairly
the same.
consistent way. Everybody
Wow.
else has to reverse engineer it.
So, on the timing of VRAM too, that's another thing. I mean, HP is, in my opinion, excessively aggressive and optimistic in their time frames for what they call memristors. What do you think is the real time frame for VRAM?
Well, I'm highly dubious about HP because it's the guys from HP Labs who are so optimistic.
Yeah.
I haven't heard anybody from the HP server business stand up and say, by God, this is a game changer and
Yeah,
it's
you're going to use it in the next generation servers.
and we're going to kill the competition because we can do X, Y, and Z that they'll never be able to do. And until you get that statement, it's just lab guys going, quack,
And it is
quack,
cool
quack.
stuff.
It's
and
cool
I understand
stuff.
the optimism.
Yeah, I totally agree that it's cool stuff. But when you're talking about the uptake of it in real world products, you got to get beyond cool. You got to get to use case.
Exactly. And not only, and you also have to get to, a business case for using it to replace something else, and you have to scale up production. I mean, it's going to take at least a decade to scale something up until it's a significant part of the storage industry.
Are we going to have multiple transitions where we go from what we have now to phase change, to memristors, to maybe something else?
See, I guess I don't. I mean, the phase change guys have been yakking for years and theoretically.
Bubble memory.
Right, and so I think phase change is pretty much dead. I think what's going to actually drive it is if somebody comes up with a production process that is very close to what DRAM is today.
Yes.
Right.
Then they can make a much easier transition.
Right.
Yeah.
And
Are you talking about cost or complexity, or both?
well, really, both. Yeah, but the complexity. I mean, it needs to be, or it needs to be very similar to how you produce flash today. Right, or you need to be able to run it on the same production lines because nobody's going to build a $2 billion resistance RAM fab just betting on the come.
Right.
So if you can take existing production systems and use them to create resistance RAM, that's probably going to be the early lead in the race. And then it's really a question of, okay, do people actually come up with applications for it? Now, I think in smartphones, for example, it might make sense. You can get rid of a gigabyte or two of RAM, and so even if it's more expensive than flash, if it's cheaper than RAM, you might have an economic case for it.
Yeah.
But there's issues of, gee, what's the density actually going to be? Is it going to be as dense as RAM? When?
And we don't know.
And we don't know. So, but there's a hell of a lot of investment going on in the area, and the scientists and the engineers are pretty excited about it, and somebody's going to make a hell of a lot of money. It's just a question of when.
Well, the other key point from those slides was that even though they're claiming number of writes that's orders of magnitude beyond what flash has, it's still not exactly infinite. You still have lifetime issues. You're still going to need wear leveling. You're still going to need some of the stuff that's been developed for flash. It'll certainly have to be modified, but in that sense, it can't be treated just like memory, and it can't be treated just like disk because it does have these other issues that neither of those has.
So there needs to still be something between it and the system in order to control all that.
Right, and it's still you're still going to have some plan for what happens when it's reaching the end of its useful lifetime and starts becoming unreliable on you, which is where the ReFS guy...
It only has to be reliable enough to last the useful lifetime of the rest of the system. I mean, it's like flash. I mean, people complain about MLC in an enterprise and things like that. Well, if the MLC is going to last 5 years, then that's fine.
Are you assuming it's in the server?
Or in the server, in somewhere. I mean, wherever it is, it has to be somewhere.
But the useful lifetime of a storage system, if it's separate,
5 years.
that could be longer, yeah.
It's not likely to be much longer than 5 years.
Not usually.
No, I mean,
it could
what
be,
storage
I suppose,
media
but-
lasts more than 5 years? What storage medium lasts more than 5 years?
Yeah, when you look at flash arrays that are
Well,
when you look at
tape,
arrays
I
on the
mean-
enterprise, I mean they're on a 5 year, 3 or 5 year replacement cycle in most places.
And enterprises do
And how
keep
many
arrays
write
longer
cycles?
than 5 years, but they don't generally keep them for 10 years.
236,000 per month.
And they're not fully
kidding.
used after 5 years.
Yeah.
It's probably more archival.
Well, no, I mean, most people who use LTO tapes, they replace them every 3 years. Right.
I mean, they don't have to, and tape can last longer than that.
Yeah,
but
if you talk to the LTO people, no, you don't have to. But if you talk to people who are actually running production systems that rely on tape, 3 years.
Okay. I'll ask Curtis. Hey,
And
Curtis.
if
how
they're
long?
really cheap, maybe 5 years.
Yeah.
But no, none of this is reliable, which is the long-term problem for digital civilization, right? You can put a book on a shelf and pull it down 500 years later and read it. There's no storage medium that lasts more than 5 years.
As long as you keep it alive, which is why cool file systems,
Yeah.
cloud storage, object storage. I'm excited about those things because the structure can outlive the medium.
Yeah,
Right.
you scale into larger capacities for the base. If you had to redo everything when the 2 terabyte drives came out, or the 3 terabyte, or the 4 terabyte, a lot of things would have died a lot sooner.
Well, that's why you see file systems developing a lot of these reliability features, though. And checksums are just the beginning. At some point, it's going to be erasure codes,
Exactly,
ECC,
erasure
et
coding.
cetera.
Yep.
then you have to do scrubbing, which you're seeing in more and more file systems, because you just can't let the data sit there. It will rot.
Absolutely.
You have to scrub it. You have to regenerate it. With ReFS, they were talking about detecting individual errors without indicting the whole disk. So that's actually going to be an important thing, although there's some really nasty complexities there.
Yeah, Microsoft has been working hard on the check disk system as well. And speaking of that, even in NTFS. So.
Yeah, Christine, you brought up a good point a minute ago about long-term. I was talking to somebody a couple weeks ago, and they were like, "What happens when all this stuff fails?" And it's like we have a digital dark age potential if we don't get this stuff right. In 1,000 years, they're not going to have any history of our civilization.
Well,
They'll just have my tweets.
It's the Library of
right.
Alexandria problem.
Yeah.
Right. In ancient Egypt, they had hundreds of thousands of manuscripts in Alexandria, Egypt, and somebody came along and set fire to it.
Was it you?
And it burned for days and days. No, in that particular era, I think I was a Zen monk. I have to check my past life registry, but
it's a good point. Yeah, what happens if all our digital stuff is burned?
yeah, what if? That's the whole
Electromagnetic
fear
process.
of the EMP problem.
Did anybody watch Revolution last night?
No.
I'm kidding.
But
That's what happens.
yeah, so it's a real issue, and there were these guys up in Utah working on the 1,000-year DVD. And I'm like, okay, so the DVD lasts 1,000 years, but what's going to read it?
Yeah.
And what about civilization?
In
Who's gonna
20
read it?
years, what's going to read it in 20 years?
And do we really want them to read it?
The aspect of what's going to read it that scares me is as encryption becomes more and more widespread for storage.
Yeah.
It's like, sure, the data's there. Too bad we don't have the keys anymore.
Encryption plus bit rot.
So we better have quantum computers so we can decrypt it, right?
We'll also have to have a key to explain what Gangnam Style is to the future generations of.
How about for this generation?
Exactly.
Yeah.
We could carve it on a metal plate
There we
and put
go.
it on the side of something.
Yeah, that's a
A
good idea.
satellite,
Send it off into space.
Yeah.
Right.
And
have it come
eventually
back
Miss
and-
Universe will come and get us.
And then it'll come back and get us. Yes, thank you. We've all seen. Yeah. So
That
I
was
guess
2 Star Trek references that we've
there
heard
was
so
a
far.
lot of them. Yeah.
Search for Spock in motion picture. I'm proud of this group. Now 3.
Okay.
Would this be a good place for a colorful metaphor?
Oh God! Now we've had 4. It's all 4 movies covered, guys.
Well, I guess we should probably wrap up. The next session's starting. So, great show. I'm glad that you guys are here. I'm glad that you guys can talk a little bit about what's being discussed. We'll catch up tomorrow with more. But before we go, I would actually like to take a moment to say goodbye to a friend of SNIA, a friend that we've seen at a lot of storage shows. Howie Goldstein passed away, and I'm going to miss you, Howie. So my thoughts are with his family. So thank you again for joining us here from Storage Developer Conference, and we will see you guys, tomorrow.
Yeah. Ciao.
Ciao. Does anybody know any other languages?
Nope.
Oh, that's Italian.
Didn't we do that
Need more
yesterday?
languages.
What's Klingon
Auf
for goodbye?
Wiedersehen.
Include goodbye.h.
All right, we're done.